Hey, welcome to The Explainer. Today, we're getting into something you see all the time in the news, the numbers of life and death. You know, the core stats that public health experts use to figure out what's going on with our health. But what do they actually mean? Let's break it down. Okay, so picture this. A new disease is spreading. The news reports are just flying around nonstop. It's easy to get overwhelmed, right? So the big question is, how bad is it really? How do you cut through all that noise and get a real handle on the risk? Well, to do that, you've got to understand how the experts are counting and what those numbers are truly telling us. So, before we even get into the math, and don't worry, we'll keep it simple, we have to ask a more basic question. Why do we even count deaths so carefully in the first place? It turns out every single count serves a dual purpose. It's part legal and part, well, it's the very foundation of our public health defense system. So, on the one hand, a death certificate is a super important legal document, for things like inheritance, settling estates, and preventing fraud. But for what we're talking about today, it's the public health side that's absolutely critical. Just think about it. When a health official starts seeing a sudden spike in death certificates all listing the same cause, say something like COVID-19 or TB, that's a massive red flag. It's an alarm bell. It tells them a specific threat is on the rise and they need to move and move fast. This data is literally the foundation for how they plan, where they send resources, and ultimately how they save lives. But, it's not a perfect system. Of course not. Sometimes deaths just don't get reported, or maybe the cause of death isn't identified correctly. This can leave gaps in the data, which is a huge challenge for officials who are just trying to get the clearest picture possible. Okay, so we know why we count. Now let's get into the how. Epidemiologists have this core toolkit. 3 key concepts that let them make sense of all this data. They are rate, ratio, and proportion. Let's dig into what each one of these really tells us. First up, we've got the rate. The best way to think about a rate is like a speedometer for a health event. It's not just about how many people were affected, but how fast it's all happening within a certain group of people over a specific time. It gives us a real sense of urgency, the speed of the problem. Next up is the ratio. This one is pretty straightforward. A ratio lets us compare 2 totally separate groups. So for example, if you compare the number of doctors to the number of nurses in a hospital, that's a ratio. One group isn't part of the other. They're just 2 distinct things we're putting side by side to see how they stack up. And that brings us to proportion. Now this is where it gets interesting, and it's a little different from a ratio. A proportion is also a comparison, but here's the key. The group on top, the numerator, is actually a part of the bigger group on the bottom. The easiest way to think about it is a pizza. The slice you're eating is the numerator and the whole pizza is the denominator. So if, say, 33 students out of a class of 100 pass their exam, that 33 is a proportion of the whole class. So let's just nail this down because it's super important. With a ratio, you're comparing 2 separate things, like apples and oranges. But with a proportion, you're looking at one part of a whole, a slice of the pie. It seems like a small difference, but trust me, getting this right is absolutely crucial to understanding health stats correctly. All right, we've got our toolkit. Now let's put it to work. We're going to start with the most basic, big picture measurement there is, the crude death rate. Let's actually build this formula together, piece by piece. It's not complicated, I promise. The very first thing you need is your numerator. That's just the total number of deaths that happened in a certain place over a certain time, usually 1 year. Okay, so you've got your number of deaths. Now, what do you divide it by? That's the second piece. The total population of that same area. And here's a little pro tip. We use the population from the middle of the year. Why? Because it gives us a good, stable average that accounts for people being born, people dying, and people moving in and out all year long. And there it is, the whole thing. You take your total deaths, divide by that mid-year population, and then you multiply it by a nice round number, usually 1,000. What you get is a single clear number, like 10 deaths per 1,000 people. And that makes it really easy to compare what's happening this year versus last year, or in this city versus that city. But here's the thing. While this number is really powerful, it's also, it's crude. It's very general. It tells you the overall risk of dying in that population, but it doesn't tell you who is dying or why or what age they are. It's like a snapshot of the landscape taken from 30,000 feet up in a plane. You see the big picture, but none of the details. So to get those crucial details, we need to zoom in. We need to get closer. And that's exactly where specific rates come in. They let us build a much, much richer picture of what's really going on. Yeah, I really love this comparison. If the crude rate is that 30,000-foot view from the airplane, then specific rates are like being on the ground with a magnifying glass. They let us focus our lens on one particular cause of death, or a specific age group, or really any other detail we need to investigate. And this is where the real public health detective work starts. We can calculate the death rate just from tuberculosis, or we can look at the infant mortality rate, which focuses only on the tragic deaths of children under 1 year old. We can even calculate weekly death rates to track the absolute peak of a bad flu season. Each one of these specific rates is like a vital clue that helps solve a larger public health puzzle. All right, now let's use our new toolkit to answer one of the most pressing questions that comes up during any new outbreak. Just how deadly is this thing, anyway? I mean, this is the question that's on everyone's mind, right? It's not about your risk as part of the general population. It's about the risk for the people who actually get sick. If you get it, what are the chances? How deadly is this illness? And the tool for answering that exact question is the case fatality rate, or CFR. And notice, it's a rate in name, but it's really a proportion. We're looking at a part of a whole. You just take the number of people who died from a disease, and you divide it by the total number of people who are confirmed to have that disease. What you get is a percentage, and that percentage tells you just how fatal an illness is for the people who catch it. It's a really powerful measure of a disease's severity. Okay, so we've unpacked the epidemiologist's toolkit. We've talked rates, ratios, crude counts, specific counts. But this isn't just about math. It's not an academic exercise. So how do these numbers actually save lives? Let's connect all the dots. It's because these aren't just abstract numbers on a spreadsheet. They are powerful tools that turn the chaos and fear of an epidemic into a clear, understandable threat. They are the roadmaps that guide officials on where to send doctors and medicine, what policies to put in place, and, this is key, how to measure if any of it is actually working. At the end of the day, this is the language we use to fight disease and protect our communities. So the next time you see a health statistic flash across your screen, you'll have the toolkit to see it differently. You can start asking the right questions. Is that a crude rate or a specific one? Are they comparing two separate groups, or is it a proportion? Understanding that difference, it isn't just about being smart or informed, it's about truly understanding the nature of the world around us. Thanks for joining us.